So January 2019, Unit 2. The first question, which molecule is planar? So to be a planar molecule, the bond angle should be 120 degrees. So here, when we talk about ethane, we have four bond pairs are there. So when four bond pair, it will be tetrahedral. Both of them are tetrahedral. When we talk about ethanoic acid, in ethanoic acid, CH3 bonded with C double bonded with O and H. And oxygen will, so different angles are there. This will be bent or V shape. Because of this one, it will be trigonal planar, and this one tetrahedral. So all three are there. But whenever we talk about methanol, so which is C double bonded with O and H is there and H. So three bond pair and no lone pair. Like when we consider a double bond in predicting the geometry, we consider as a single bond. So it will be a trigonal planar. And methanol, when we draw the structure of methanol, CH3O. So this will be tetrahedral. This will be a bend or a V shape. Which molecule contain bond angle of 90 and 120? So SF6, all the bond angles are 90, no 120. In PCl5, it will be trigonal pyramidal. So these angles will be 120 and these angles will be 90. In BCl3, it will be trigonal planar with a bond angle 120. And BeCl2, it will be a linear structure. Which molecule has the most polar bond? So polar bond depends on the electronegativity. Greater the electronegativity, polar the bond. So, and as we move across the period, electronegativity increase. So here nitrogen, oxygen, chlorine, and iodine. And as we go down the group, electronegativity decreases. So we have nitrogen, oxygen, then fluorine is there, and then chlorine and bromine and iodine. So in this range, we have the most electronegative. So because down the group electronegativity decreases, so C and D cannot be. Then we are left with oxygen or nitrogen. So oxygen is more electronegative. So its bonds are more polar than nitrogen. Because greater difference in electronegativity, polar the bond. Which is a correct for tetrabromomethane, CBr4. CBr4, it will, the polarity of the bond, because two different atoms, different electronegativity, bond will be polar. But molecule will be non-polar because a symmetrical molecule, so they cancel out the effect of each other. So bonds are polar, but molecule will be non-polar. So D will be the right answer for this. The next is, in alkanes, increasing a length on the branch both affects the boiling point. Which of the following combination effects is correct? If we increase the length, the boiling point will increase. And if we increase the branch, the boiling point will decrease. Because if it increase the branch, the surface area reduce. As a result, the boiling point will decrease. What is the correct order? What is the correct order of boiling temperature of a hydrogen halides? So what actually happened? Hydrogen fluoride will have a hydrogen bond. It is greater than hydrogen. When we talk about the, so this will be HCl, then we'll have HBr and then HI. From lowest to highest, so lowest will be HCl, then HBr, then HI, and then HF. Why? Because this will have a hydrogen bond, this will have dipole force, and this will have dipole induced dipole force. But dipole induced dipole forces increases as the number of electron increase. What is always formed when S block nitrate thermally decompose? So S block nitrate means group 1 and group 2. So whenever a metal nitrate is heated, what, like group 1 or group 2 nitrate is heated, what it will form? It will always form, like when we heat sodium nitrate, as a result of thermal decomposition, it gives sodium nitrite plus oxygen. And if we heat group 2 nitrate, like example, magnesium nitrate, so it will give magnesium oxide plus nitrogen dioxide plus oxygen. So what is always formed when we decompose the S block nitrate, group 1 or group 2, it will always form oxygen. Metal nitrite is formed with group 1, but not with group 2. Metal oxide is formed with group 2 only. Nitrogen dioxide with group 2 decomposition. But oxygen is formed when we decompose even group 1 or group 2. When solid potassium bromide react with sulfuric acid, which substance is not formed? So potassium bromide KBr is there. First it reacts with sulfuric acid H2SO4. So first it will form potassium hydrogen sulfate plus hydrogen halide HBr is there. This is called acid-base reaction. And then the HBr, in which the bromide ion is good reducing agent, it will, what are the products which can form when a, like a sulfur in sulfuric acid oxidation number is +6. So the possible products are there. It can form bromine molecule, like the product of a sulfur. It can form sulfur, it can form sulfur dioxide, or it can form hydrogen sulfide. But hydrogen sulfide, when we check the like the change in oxidation number, here it will be 0. Each oxygen is -2, so 2 will be -4, so sulfur is +4. And here this is +2, so this will be -2. So this is a, because in sulfuric acid, sulfur is +6. So it can, it is good reducing agent, but the best reducing agent is iodide. When it react with iodide, then it will give a hydrogen sulfide, which give a pungent smell. So this product is not possible with hydrogen bromide. Sulfur dioxide and sulfur can form. Even bromine can also form. So HBr is there, bromine is there, sulfur dioxide is there, but hydrogen sulfide, because hydrogen sulfide, it should reduce the sulfur from +6 to -2. Means the change in oxidation number for sulfur is +6 to -2 when it forms hydrogen sulfide from sulfuric acid, which is a very low reduction, like greater amount of reduction. That's why this is not possible with HBr or potassium bromide. It is possible if we were using potassium iodide. So if we use potassium iodide, all products will be there. But if you use potassium bromide, the first reaction which produce HBr, and then the bromide ion react with sulfuric acid, which reduce the sulfur to lower oxidation number, but not to -2. So you have to memorize the products whenever a hydrogen halide reacted with sulfuric acid. It is a very important part. Which equation does not represent this disproportionation reaction, means the same element is oxidized or reduced? Here chlorine is 0, hydrogen is +1, oxygen is -2, so chlorine should be +1. And here +1 and -1. So chlorine 0 become +1 and 0 become -1. So this is a reaction in which the proportionation happen. When we check the second one, chlorine is 0 here. Each oxygen is -2, 3 will be -6. Potassium is +1, so chlorine is +5. Here +1 and -1. So 0 become +5, 0 become -1, so oxidation and reduction happen. So this is also disproportionation reaction. When we check C, potassium is +1, oxygen is -6, each is -2, 3 are -6, so chlorine is +5. Here +1, -1 and 0. So the same element should oxidize and reduce, but here +5 become -1, so it means it is reduced, but no oxidation happens. So that's why C should be the right answer. And what about this one? +1, +5, -6. So +1, -8. So this should be +7, and +1 and -1. So +5 become +7 oxidation, and +5 become -1 reduction. So this reaction also same element. Question 10. How does the addition of a catalyst to reaction affects the shape of the Maxwell-Boltzmann distribution curve? So in a Maxwell-Boltzmann distribution curve, like this is a graph we have. If we use the catalyst will lower the activation energy. Like this is example, the activation energy without catalyst. If we use activation catalyst, it will lower the activation energy. So what happened to the shape of the graph? The shape of the graph does not change. The shape of the graph changes if we change the number, like the temperature. If we change the temperature, if we increase the temperature, then the peak will decrease and it shift towards the right hand side. If we lower the temperature, the peak will increase and shift toward left. Or if we change the number of the particles, then the surface area of shape in that sense will change, like total area will change if we change the number of the particles. So there will be no change if you use a catalyst. Catalyst only alter the activation energy, lower the activation energy. This question is about the equilibrium between the sulfur dioxide, oxygen, and sulfur trioxide. What are the effects of decreasing temperature? The forward reaction is exothermic. So for exothermic, if we decrease the temperature, equilibrium will shift towards the right hand side. So yield, or if the equilibrium shift towards the right hand side, the yield will increase. But rate is directly proportional to temperature. So if you reduce the temperature, what will happen to the rate? The rate will decrease. Means this reaction will give a higher amount of sulfur trioxide, but it will take much longer time. So the yield will decrease and the equilibrium concentration will increase. What is the effect of increasing the pressure? Pressure also increases the rate of a reaction. So the rate will increase. And what about the position of equilibrium? Because the yield is, so here we have one total 1.5 moles of a gas, and here we have one. If we increase the pressure, equilibrium shift towards the side of less moles of the gas. So both will increase, the rate will also increase, as well as the shifting of equilibrium toward the right hand side, so yield will also increase. The equation for this reaction can also be written, the enthalpy change of this equation. Look what we did. We have 1.5, and 2 moles are there. And now we just like multiply that by 2. What will the enthalpy change of this reaction? So enthalpy change as we change the moles. So this is when 1 mole of a sulfur trioxide is formed, it was minus 98 kilojoule for overall reaction, enthalpy change for overall reaction. Now the equation of this reaction, we just change, we multiply all of them by 2, means 2 moles of sulfur dioxide, and give, so the enthalpy change of this reaction. So what will happen to the enthalpy change of this reaction? As all the quantities are being doubled, so enthalpy change will also be doubled. So 98 multiplied by 2, it will be 196. Because, like example, if H2 plus Cl2 gives 2 HCl. For 2 moles of HCl, if example, we were having 100 kilojoule per mole. Now we reduce to half. So if we have half mole of hydrogen, half mole of chlorine, and we have 1 mole of HCl, so this will be 15 for 1 mole. So enthalpy change will change as the number of the moles be changed. A sample of a 50 cm cube of ethanol burned completely in 200 cm cube of oxygen. All volumes are measured at 400 Kelvin and 1 atm. What is the total volume of the gas when the reaction is complete? Look, first we have to find unreacted reactant and the formed product. So for what is a limiting reagent? If we check C2H5OH and oxygen, the ratio between them is 1:3. 1 mole react with 3 moles. So if we have 50 cm cube, because when we take, it's a gas, so ratio of the moles and ratio of volume will be same. So we can just take the volume ratio. It will be X cross multiply. So it means we need 150 cm cube of oxygen, but we have more than, we have 100, we have 200 cm cube. So what will happen? This ethanol will be used up completely. And how much oxygen we are left with unreacted? Because 200 was the total, 150 is reacted. So how much ethanol unreacted? 50 cm cube unreacted oxygen. Then carbon dioxide and water vapor, both are gases. So we'll take a ratio. So and we always take a ratio from the limiting reagent. As ethanol is a limiting reagent, the ratio between ethanol and carbon dioxide is 1:2. So if we have 50 cm cube of ethanol, x cm cube of carbon dioxide, so it will be 100. So 100 cm cube of a carbon dioxide will form. And how much water vapor? Again, you will take a ratio between the limiting reagent and the product. So 1:3 is the ratio. So if we have 50 cm cube, this will be X cross multiply. The amount of a product depends on the limiting reagent. So 150. So 150 water, 150 cm cube of a water vapors, 100 cm cube of carbon dioxide, and unreacted 50 cm cube of oxygen. So if we add them, 150 plus 100, 250 plus 50 makes 300. So D will be the right answer for this, because it's unreacted reactants and the formed product. Is it clear, this one? Then which is a tertiary alcohol? Tertiary alcohol means the carbon which is attached with oxygen should have 3 alkyl groups. When if 3 alkyl groups are there, that will be a tertiary alcohol. So if you draw the structure of bute and 2-ol, so bute means 4 carbon will draw. Second position we have OH. Second position we have a methyl group. Methyl means like carbon group. So this will have 3 hydrogen, this will have 2 hydrogen, this will have 3. So you can see the OH is attached with this carbon. And with this carbon, this is one carbon chain, this is a second carbon chain, and this is a third carbon chain. So 3 carbon chains are attached. So which type of alcohol is this? This is a tertiary alcohol. Tertiary alcohol is having 3 carbon chains around. If it was a primary, 2 carbon chains. If it was a, primary, 1 carbon chain. Secondary, 2 carbon chains. Excess of ammonia is ethanol with 1 bromobutane at high pressure. Which products could be formed in this reaction? First, we have 1 bromobutane. So C4H9Br is there, reacted with ammonia. Ammonia is NH3. In which the distribution, like NH is partial negative, NH is partial positive, and here bromine is partial negative and carbon is partial positive. Now first, when the reaction will happen, it's a substitution reaction, so NH2 will take position of a Br and Br will take position of NH2. So as a result, the first product will be C4H9NH2 means amine, butylamine plus hydrogen bromide or HBr. This hydrogen bromide is acidic, like hydrogen bromide, hydrogen chloride, hydrogen iodide. They are acidic in nature. And we have using excess of ammonia. If you are using excess of ammonia, then what will happen? This HBr will react with ammonia. When HBr will react with ammonia, so it will produce NH4Br, ammonium bromide will be there. So ammonium bromide will be one of the product and butylamine is another product. So that's why A will be the right answer. But what if the same question was there and they say limiting or limited ammonia? If you have a limited ammonia, the first reaction happened the same way, like C4H9Br reacted with ammonia NH3, in which NH2 is partial negative, H is partial positive. So it will form C4H9NH2 plus HBr. This time ammonia is a limiting, so this HBr is not able to react with ammonia. Then what will happen? This C4H9 C4H9 NH2 will react with another halogen like this C4H9Br, which is the main reactant, will react with a product C4H9NH2, and the multiple substitution, multiple hydrogen will be replaced. So as a result, it will produce C4H9NH, then C4H9 plus HBr. So means this will happen until all of the hydrogen will be replaced. When we use a limiting, but usually we use access, so the access will give us the butylamine and ammonium bromide, not hydrogen bromide, because the hydrogen bromide will react with ammonia to form ammonium bromide. This question is about the mechanism and the type of and reaction types. The reaction between alkane and halogen to form a halogen alkane is what? So when alkanes reacting with like chlorine, so it is the free radical substitution reaction. If you remember, like first the chlorine, it produced a chlorine radical. This was in unit 1. And then methane reacted with chlorine radical from methyl chloride. So this is free radical substitution reaction. Reaction of ammonia with halogen. Just now I explained, like it's a substitution reaction. In which substitution? It's a Why nucleophilic? Because like if we have a halogen alkane, say C4H9Br, the same example. This is partial positive negative, and ammonia is there, NH2 and H, negative and positive. So this ammonia is partial negative, it attack on the positive center, and the substitution happen because it attack on the positive center, so it's a nucleophilic substitution reaction. Electrophilic addition reaction happen in alkenes. If alkene was there, like alkene react with any reagent, then it will be electrophilic addition. Question 16, which of these compounds cause the greatest amount of the anthropogenic global, means which are caused by like leading to a global effect, greater greenhouse effect or a global effect. So, and anthropogenic means like which are mainly because of the human activities. So carbon dioxide, is mainly causing a global, methane is also causing a global warming, but our activity does not emit too much methane. But for example, burning of fossil fuel, burning different types of compound release carbon dioxide. So due to the human activities, which compound is causing a global warming? That is the carbon dioxide. Methane is a higher greenhouse factor, but it's not released by us. It's like a trapped methane in the ice caps that is there, or the farming, cattle farming also contribute to emission of the methane. In which pair both substances deplete the ozone? So which substances are ozone depleter? CFCs and oxides of nitrogen both can, so difluoromethane and nitrogen monoxide both can cause depletion of ozone. But not water vapor, so this is not wrong. This is also wrong. Carbon monoxide is also wrong. This is correct. This one is wrong. This is correct. So which one? Both of them, carbon monoxide and the difluoro, like CFCs, chlorofluorocarbons, it leads to depletion of the ozone.